All right, welcome back. Now, previously we got to understand word embeddings, okay? And over there, I told you that we have two main techniques that we use when it comes to word embeddings, right? Generating word embeddings for your test, okay? And I told you that we have word to vec and then we have glove, okay? So we're going to now discuss word to vec, okay? What it is and why we need that. Since we already discussed bag of wares and also TF-IDF, okay, and then we got to understand that with bag of wares and also TF-IDF we can represent our test in the form of digits where we can feed to NLP algorithms to build models. Okay, but we said that they are not enough. There are some kind of constraints over there when you're using bag of wares or you're using TF-IDF. Okay, so we propose more advanced techniques over there, which is word embedding, and under that we said that we have word to vec and glove. All right, so now let's start by getting an understanding of why we need the word to vec in the first place. All right, so as I said, we first discussed the test vectorization techniques, bag of wares, and then TF-IDF. So the challenge here is that when you're using the bag of wares or when you're using the TF-IDF, we lose what we refer to as semantic information. Okay, we lose what is referred to as the semantic information, right? And the semantic information is nothing but the context or the meaning of the sentence. Okay, so for instance, if I have a sentence like I like, let's say I like NLP, okay, something like that. Now, if I'm using either bag of words or TF-IDF, what it's going to do is that it's going to represent these things with numbers, okay, and bag of words is just going to look for the frequency of the words, okay, and also similar to the TF-IDF. So here, the sequence of these things is not going to matter. It's just all that it cares about is how frequent each of these words appeared, okay, how frequent it's appeared. So let's say this is quite a huge test, right? It is quite a huge a huge test, so, or maybe a test that contains about 1,000 words. Okay, so how many times did I appeared, how many times did like appeared or NLP appeared? That's the thing that these ones are going to focus on, okay? And whilst doing that, it's not going to care about which came first. For instance, you cannot say like I NLP, okay? You cannot write this sentence like this, like I NLP. Okay, this one does not make sense. Okay, you cannot do maybe NLP, right? NLP like I, okay, something like this. It doesn't also make sense. But this one, the sequence over here makes sense, right? The context of the NLP coming at the end here makes sense. Okay, so this context, this semantic, we lose it when we're using these kind of things. Okay, bag of words and then TF-IDF. Okay, now in order to preserve that kind of semantic information, we use what is called word to vec. Okay, we use what is called word to vec. So let's see what this word to vec actually means. All right, so as I said, if you're using this bag of words or the TF-IDF, right, you lose the semantic information. So this is an example for you to further understand what I mean by that. So I have this sentence over here. You can call it corpus because that's all we have. Okay, so this is I like deep learning, I like NLP, I enjoy flying. So this is the the corpus that we have: one sentence, two sentences, and then three sentences. So if you want to use tokenization on this corpus, then you're gonna have it like this: I will be on its own, like will be on its own, enjoy deep learning, NLP, flying, they will be on their own. Okay, so now once and then dot, of course, will be on its own. Once you do that, we now represent these things, right? We now represent these things in the form of what we refer to as coherence matrix. Okay, what is referred to as coherence matrix? Let me write it here for you to see. Co-occurrence. Okay, coherence double R. Right, coherence matrix. Okay, so we represent it like that. That is, you have it here, you have the same matrix here, you have the same matrix here. So it's just coherence, okay, occurrence. You can think of it as your colleague, okay. This one, the colleague is here, so co-occurrence, okay. It is occurring 2 times over here. So the only thing that we're trying to do is that, so here, how many times did, let me just clean some parts so that we have, how many times did I and then like appeared, right? So I and like, we have one of them, I and like another one, so they appeared 2 times. Okay, how many times did I and then enjoy appeared? Okay, I enjoyed appeared 1 time over here, so we have it here, right? How many times did I and then deep appeared? There's nothing like that, so it's 0. I and then learning, nothing like that, so it's 0. I and NLP, nothing, so it's 0. I and flying, nothing. I and dot, nothing. Okay, and then I and like, okay, or like and I, right? They appeared 2 times as we saw over here. Okay, so just like that, it's just going to be like that. How many times did learning and deep appeared, right? So let's see whether we have any learning and deep right here. They appeared 1 time. Okay, whether it appeared, either ways, whether learning came last or learning came first, either of them. Okay, so it appeared 1 time. So learning and deep, it appeared 1 time is there, right? You can see it there. Okay, so that's basically what it's going to do, right? So it doesn't really care about the sequence of this one, the context that the word is appearing. It doesn't really give, it doesn't really care about it. Okay, it doesn't give attention to that. Okay, so that's what we do. We just represented them in a form of a cocherence matrix, and that's it, right? So that becomes a challenge over there, right? Now, the solution here is using word to vec. Okay, the solution here is using word to vec.